Fire can break out and develop in many different ways. It is impossible to describe and predict every specific type of fire development, but we can provide a general understanding of how a compartment fire develops. Emergency services often arrive at structural fires at the pre-flashover phase. They can easily find themselves in life-threatening situations caused by failure to recognise the signs of imminent flashover and take appropriate precautions. Often the situations that look the most hazardous are not, while sometimes the routine fire turnouts are often the most dangerous. This video and the practical component is designed to give emergency services the chance to witness the signs of the development of flashover and backdraft, and provides them with the methods which will help them to avoid becoming victims themselves. Live fire training is important to maintain current skill sets. However, the use of A and B class materials in high concentration is dangerous to human health. The use of C-class training plops and scaled models ensures the health and safety of our people is not compromised.
So we understand the basics of combustion in that there's 4 elements that we need for that, being heat, fuel, oxygen, and then with that the chemical chain reaction. Those 4 elements together will create our flaming combustion. Once we have flaming combustion, there's 3 types of heat transfer: convection, conduction, radiation. So let's now put that into context of a building fire. So we can call a building fire a ventilation limited fire, in that the thing which is the limiting factor on the size of this fire is how much oxygen is available to it. A ventilation limited fire will go through 4 distinct phases, being the incipient or the ignition stage. Those 2 words can be used interchangeably, it means the same thing. The growth stage, fully developed, and then finally the decay stage. So let's break those down a little bit further and go into detail for them. So the incipient stage or ignition stage, let's say we've got a little chair in the corner of the room. It's had some sort of ignition applied to it and it started some flaming combustion. So at this stage, the main driving heat wires is the convection current, yeah? So that's hot air moving upwards, being less buoyant, and then cool air coming in. So we have nice cool air filling our combustion zone full of new oxygen and pushing all of that hot products of combustion away. Once that's gained a little bit of steam, it'll move into the growth stage. Once we get to the growth stage, the main driving force heat wise is the radiant heat. So it's going to be radiating off of where our fire started and preheating all those other little bits of fuel inside of the room. So those other bits of fuel will start to chemically decompose, break down, and that's what we like to call pyrolysis. And the gases coming off of that we would then call pyrolysis gases. But for today we'll just call it smoke, yeah? So our main fire, radiant heat, breaking down the other bits of fuel inside the room, filling the room full of smoke. The next stage from that is the fully developed stage. And the sort of buzzword we use there is total surface involvement. So that's every single bit of combustible material inside of the room reaching its auto ignition temperature and going into flaming combustion at the same time. The next stage after that is the decay stage. So that's where the available oxygen inside of that space has been depleted, and so therefore the fire tetrahedron is missing that oxygen element, thus putting our fire out. Some key points to mention through all of that. In between the growth and the fully developed stage is a phenomenon that we call flashover. So that's just the sort of description of that total surface involvement. So everything inside the room meeting its auto ignition temperature. So if we as firefighters are inside of a room while it goes in flashover, going from that growth to fully developed stage, we ourselves are fuel. So thus, in here is a dangerous place for firefighters to be. The next part here is in the decay stage. We can get this phenomenon called backdraft. So if we imagine a room in its decay stage, it's full of fuel, it's full of heat, it's only missing that oxygen. So if we come along to a building fire in decay and we then open a door, that will let some oxygen in and create this backdraft. So that's where we've got all those elements inside the room bit of oxygen comes in, it's already hot enough, and it will go into flaming combustion straight away with like a sort of an explosive reaction. The other time that can happen is if your building fails. So let's put that in context for mining with our little transportable dongers, that sort of thing. Pretty weak buildings, they can fail, letting oxygen in and then creating a backdraft. So now let's move over to our wooden box, and we'll put that into a practical context by lighting a fire in the corner, and we'll show a flashover, and then eventually we'll try and get a backdraft. We'll see how we go.
So we start off now with the fire in the ignition stage. This is just simulating a fire in the corner of the room. Let's say it's an office chair or a computer, that sort of thing. So starting in its ignition stage, this will have the convection current, lifting all of those hot gases up and pulling all of those, well, that cold air back in to help fuel the fire. So from here it'll start moving into the growth stage. Once again, the growth stage, that's that radiant heat starting to break down all the other bits of fuel inside of the compartment in that a little thing we like to call pyrolization. So all those little fire gases or the smoke will start to mix with the oxygen inside the room, and of course it's hot as well, so that'll get all those things up to their auto ignition temperature. That's where we get our flashover and we'll move into the next phase, which is the fully developed stage. So if we look a little bit closely at the bits of fuel on the right hand corner there, just where I'm pointing to, you can see the little bits of smoke starting to come off it. So that's just sort of the back end of your growth stage there. And right now, before you know it, we'll get into flashover. So you can really see it now, all those little bits of smoke coming off of those other bits of furniture. So now we're into the fully developed stage, and you can see here now that bit of furniture in the corner of the room that wasn't involved in fire, now totally involved in fire. So this is the fully developed stage. Right now this is a fuel limited fire because we've only got one wall open. So we'll change it to a ventilation limited fire. Now this fire's in decay stage. But you'll see very quickly, as soon as we pull that door back off again, we get that influx of oxygen, creating a backdraft, and then our fire goes back into the fully developed stage. So let's do that again. We'll put the door back on, making this a ventilation limited fire, goes into decay, pull the door away, and then we get backdraft back into a fully developed fire. Now that backdraft can be caused by a window failing, the building itself failing, or us just turning up, opening the door as firefighters often do. We'll go through this a couple times again. So again, we're from the fully developed stage, going into the decay stage, and then once we get a bit of oxygen available, we get a backdraft and we go back into the fully developed stage. Now just on the right hand side here, I'm spraying the wall with water to show the under pressure zone, the over pressure zone, and the neutral plane. So you see where I put the line there, that's the neutral plane. Above it is the over pressure zone, below it is the under pressure zone. So now we'll do another little backdraft. You'll notice just before it starts that flame combustion again, you'll see the smoke change colour from that grey, goes in sort of like a green browny sort of colour. That's a sign of an imminent flashover or a backdraft. So now we're showing an advanced firefighting technique for extinguishing a building fire. We're just limiting the oxygen to the room by closing the door, and then we'll open it, have our water on a sort of wide fog, spray it into that smoke layer at the top of the room, bring the temperature down, so we end up being able to get a fire into decay stage but without any of that heat, so there's no chance of backdraft. And we see here now the normal atmosphere outside of the smoke, and as we get closer to the door, we don't even need to get anywhere near the door. You can see our carbon monoxide levels are pretty high there, so not an atmosphere you want to be in without BA. thus reinforcing all of our Barrio principles.